The technique that was explained right now is known as PCM. The essential features of the technique are as follows. The PCM technique that stands for pulse code modulation has 3 steps. Step number 1, take samples at regular intervals. Step number 2, assign digital values for each of the samples. And step number 3 is convert the digital values to binary format. That information can now be processed using a computer and transmitted over digital lines because of the fact the audio that was originally sampled is now represented in binary digital form. There are certain important factors that needs to be considered in this digitization process. The first one, as explained earlier, is the sampling rate. The more samples that we take, the better the quality of the digitized information. Why is that so? Look at this audio. If we take closer samples, in other words frequent samples, then when we transmit the information, when it is received on the other side, we could approximate the original waveform in a better way because we have more samples. This sampling rate is usually measured in hertz, in frequencies. For example, if we say the sampling rate is 2 hertz, then we mean 2 cycles per second. That means we are taking 2 samples every second. So sampling rate is measured in hertz. The second important factor to be considered is known as the sampling depth, which is the number of digits that we use for representing these heights. For example, take this audio wave. Let's say that we are taking samples 10 times each second. So the sampling rate is 10 hertz, and we can use different sets of digits. In this case, let's say we are using 8-digit sampling depth. That means we are using 8 digits to represent the height. In this case, it would be, let's say, 0 1 0 0 1 0 1 0 to represent this height. Again, the more the number of digits that we use, the better the quality of the audio that we capture. So the quality of the audio that we capture will depend on the sampling rate as well as the sampling depth. The higher the sampling rate, the better the quality. The higher the sampling depth, the better the quality as well. But there is a price to pay. As we make either of them higher or both of them higher, we will require more storage to store the digitized audio. We would also require more bandwidth to send the digitized audio. So these are 2 considerations that we should bear in mind. Now here are some examples on sampling rates and sampling depth. In the case of CD audio, that's the songs that are available on CD, the sampling rate is 44,000 hertz or 44 kilohertz approximately, and the sampling depth is 16 bits. And of course, the audio is recorded on 2 tracks because we need stereo output. This will determine the storage requirement for the CD. We can compute the storage requirement in this case by taking these factors into consideration. The audio that you are hearing in this presentation, that is audio presentation, the parameters that were set for recording this presentation were as follows. The sampling rate is 11 kilohertz and the sampling depth is 16 bits, and there is only one track of information or audio stored in this case. So this is for this multimedia presentation. So we could see that this particular presentation will take less storage space compared to the CD presentation. How much less? We can compute that in as follows. For the CD, we require 44 times 6 times 2 divided by 11 times 6 times 1, that is about 8 times. In other words, the audio that is being recorded now requires 8 times less storage and bandwidth compared to the audio recording that we would normally use to produce CD quality audio.